everyone. Today we would like to explain the Kepler problem. So Kepler problem is very basic question to estimate the trajectory of some particle. So at that time we need to assume the kind of potential shape. So in this case we assume the Coulomb type potential shape U equal minus alpha divided by R. At that time, so one of the interesting topics is what kind of trajectory can we describe on the plane. So this is a kind of source of potential. Then we try to inject something particle to this plane. At that time, we can consider the effective force. The first term is corresponding to the potential of this particle. And the second term is centrifugal force of the system. So by assuming there are two terms, so we can write the effective potential shape like this. Okay, so let's try to describe this effective potential on this plane. So y-axis is corresponding to the potential, and the x-axis is corresponding to the length from the center. At that time, so potential U effective can be described with this shape. Then we can separate the two types solution. So one is unbounded solution. If given energy is larger than 0, at that time, so this solution is unbounded solution. But if we give energy less than 0, at that time, so this solution is bounded solution. So bounded solution is kind of oscillation. So we can observe the kind of closed loop shape. When we solve this equation, so we can categorize the trajectory like several types. So this trajectory should be a hyperbola shape like this. And in the case of bounded solution, this trajectory should be elliptic curve. So at that time, so we can describe this equation with this equation. So this one is elliptic type, and so E equal 1 is special case. So this is a circle shape, and if E is larger than 1, so this solution is hyperbola. Then we can write the trajectory like this. Then we can describe the A factor from the geometry, so like this. Today we would like to solve the equation of case 1 by assuming this configuration. Okay, let's try to solve the equation. By solving the conservation law equation, so we can estimate the time as a function of R. So we can use this equation. So now we consider the U equal minus alpha divided by R. So by inserting this factor to here, so we can get this integral. So in next step, we start the m divided by 2e term from this equation. Then we can start this term here, and also we simplify this equation as a function of R. Then we can get this equation. As you can see, so this term is polynomial of R. So by stacking this term like this, then we can simplify this equation. Okay, so please remember the definition of A and E. So definition of A and E is described with this equation. So we can insert the A and E into this equation. Then we can simplify this equation. So next step, we need to replace the factor. So we assume the R plus A equal EA cosine hyperbolic xi. And at that time, so we can calculate the differential equation of this one. Then we can insert this factor into this equation. Then we can simplify this equation. Finally, so we can get this equation, and by solving this integral, so we can get this solution. Okay. Now we estimate the time as a function of psi, but we would like to know the relation between the Cartesian coordinate and the psi. To get the Cartesian relation of Cartesian coordinate and the psi, first we assume the x and y as like this. At that time, we assume the equation of trajectory like this. So by moving this r factor to this term, then we can write this equation. As you can see, this term is corresponding to the x. So by solving this equation, we can simplify this equation. Then finally, by inserting each factor to this equation, so we can calculate the x equal a e minus cosine hyperbolic xi. So by using the Pythagoras theorem, so we can also estimate the y. So by inserting each factor to this equation, so we can get this equation. As you can see, so x and y can be described with the function of xi and as a function of xi. So yeah, by using these equations, so we can give a relation of r and t as a function of x and y. So we can perfectly solve this equation. Thank you for watching this movie. See you next time.